Welcome to my channel. So for this video, we're going to analyze the daily challenge problem. That is problem 1710, maximum units on a truck. So for this problem, here we are going to share a grading method. First, I'll read through the statement of the problem, and then look at one example, and finally we share the short code. So let's look at the statement. So we are assigned to put some amount of boxes onto one truck. Here we have only one truck. So we are given a 2D array called box tabs, where box tab consists of two elements. So one is number of boxes, and the second is number of units per box. So here it explains the meaning. So number of box I is the number of boxes of type I, and number of units per box I is the number of units in each box of type I. So we are also given an integer called truck size, which is the maximum number of boxes that can be put on the truck. So we can choose any boxes to put on the truck as long as the number of boxes does not exceed the truck size. So we are required to return the maximum total number of units that can be put on the truck. So here is example 1. So the truck size is 4. So we put one type 0 box, two type 1 box, and one more type 2 boxes. So the total number of units are 8. So this is example 1. Then example 2, the output is 91. So we will analyze this one shortly. So let's look at the constraints for this problem. So the length of the box tabs is bounded above by 1000. So this is actually a short list. So the number of boxes and number of units per box is also bounded above by 1000 and greater or equal than 1. Similarly, the truck size is greater or equal than 1 and has a upper bound 10 to the power 6. So the last two assumptions or constraints are sort of routine. So let's look at the idea here. So I would say this problem is a straightforward problem. The method we are going to use is a grading method. So I'm going to walk quickly about example 2. So we overall we want to first put the box tabs with largest or larger number of units per box elements, so corresponding to the second element in the list element. So for this, actually we need to first sort the box tabs list according to the second component in the elements. So we sort from the large to small. So example 1 is sort of special because it's already sorted if we check the second elements in each of the elements of the box tabs. So for this problem, so after we sort according to the second element, we get this list. Then the truck size is 10, so we can put 5 of the type 0 and 3 of type 1, and we have 8. Then we can put 2 more of the type 2 boxes. So we get 50 plus 3 times 9, that's 27. Then plus 2 times 7, that is 14. So overall, the return is 91. So that's the main method or idea for this problem. So for this problem, again, I think it's very straightforward, and the code itself speaks louder. So let me carry out this procedure. First, I'm going to sort this box tabs. I will sort in place. So according to the key, that is I'll define lambda function. So the item or the x, I'm going to sort according to the second element, but in a reverse order. So in other words, from large to small. So once we've done this step, we're ready to do the iteration, so do a linear scan. For that purpose, first I'm going to initialize a result. So the final state of this variable is what we want to return. And also in the process, I want to track how many boxes are in the truck, so that we can make sure it not exceed the truck size. So now we are ready to do the iteration. So we are trying to check the n boxes and the ratio in the box types. Notice now the box types is already sorted. So first thing we want to do is that we check if we can add the whole of the n boxes. That is, if on truck 1 plus n boxes is greater than the truck size or not. So if this were the case, so we cannot add all of them, so we can only add part of that. So we're going to return result plus how many boxes we can add for this type. So that is on the truck size minus the ones currently on the truck. Then for this type, the ratio will be ratio now. So that's the return. We can directly return in this case. So otherwise, what we do, so it means that we can add all the n boxes for this type. Therefore, we can update the onTruck variable by n boxes. And we need also update the result. The result is the increment in the units, that is n boxes times the ratio. So once that this part is done, we're ready to return the result. So that's the whole code for this problem. So as I mentioned, it's sort of straightforward. Let's check for example 1. Yeah, it passes. This is example 2. So it passes example 2. Anyway, example 2 is more typical than example 1. Example 1 is already sorted. So now let's do a check for generic case. Yeah, it passes the generic case. So that's about it for this problem. So you are welcome to check out other videos in my channel, and especially this problem can be regarded as a part or step in some of my videos analysis for Leetcode problem in the binary search playlist. Thank you very much.